This is a work-in-progress paper on the power of ProTAs, assessing the impact of industry professionals as teaching assistants and mentors to advance engineering design education innovations, by Lindy Mayled, Ryan Muth, Brent Siebold, and Eric Prosser from the Ira A. Fulton Schools of Engineering at Arizona State University. Capstone courses are extremely common in ABET accredited programs across a wide variety of disciplines and institutions of all sizes. Typically, these courses are required for graduation in a degree program. The benefits of mentoring during capstone courses is extremely well documented in literature. This mentoring often relies on teaching assistants to provide mentoring services. Mentoring correlates very positively with student, faculty, and sponsor satisfaction. Gaps in the literature include research on the effect of capstone courses on student success metrics and research on the impact of mentor type in capstone courses, both of which we begin to explore here. In our computer science and computer systems engineering capstone courses, we have over 400 students in a cohort each fall. This necessitates over 100 projects each academic year. At this stage in their education, students require a great deal of technical and professional mentorship to transition from the academic world to the professional world. Currently, the courses are staffed by 10 to 12 graduate teaching assistants and supervised by 1 to 2 faculty members. It has been observed that most graduate teaching assistants are not able to effectively mentor undergraduate students in these areas as they are inexperienced with both technical and professional activities in general. We propose a model to hire professional teaching assistants, or ProTAs, to assist in mentoring these students. ProTAs are industry professionals with minimum 1 to 2 years of relevant experience hired as academic associates. They serve as mentors to 6 to 8 capstone project teams, providing technical guidance, professional feedback, and evaluation through regular meetings with the teams throughout the course. The biggest contribution that ProTAs bring is the amount of time that they spent with the students in either technical consultation or providing professional guidance or project management throughout the student's project. This time investment is typically 1 to 2 hours per team per week. This paper seeks to answer the questions: did ProTA mentored students experience higher grades and lower failure rate than students mentored by graduate students from the previous year? Did ProTA mentored students experience higher grades and lower failure rates than students mentored by faculty members from the previous year? And finally, when ProTA mentored students, student data were compared with non-ProTA student data from the same year, were the grades similar between the groups? In our approach, we conducted grade and failure analysis during the spring 2018 and fall 2019 semesters. This covered 556 students, 33 of which were mentored by faculty, 391 were mentored by graduate teaching assistants, and 132 were mentored by professional teaching assistants. Projects were chosen for ProTA mentorship to augment technical expertise, such as situations where the project sponsor may not have the technical experience to effectively guide students. In these courses, students engaged in the Scrum project management process. Assessments we measured from the students included their Sprint Zero requirements report, Sprint retrospective reports, peer and sponsor reviews, semester project presentation, team project reports, as well as final grades. In the project management category, which included the Sprint Zero report as well as the Sprint retrospective reports, we saw that the pro-mentored teams received significantly lower scores on the Sprint Zero report than both the faculty and graduate student mentored groups. But during the Sprint retrospectives, they achieved slightly higher scores, though not significantly different from the faculty mentored teams in the previous semester. This may be explained by the pro mentors only being involved with the teams after the Sprint Zero report was due. We found no significant difference in the sponsor review across all of the cohorts, but we did see a significant difference between the pro-mentor teams and the graduate student mentor teams on peer review scores spring to fall. Note that this is across different semesters, so this is a different cohort of students and the dynamics might be different. We saw this trend follow into the team deliverables category, where the pro-mentor students performed lower on both the semester project presentations and the team project reports. In the final grades, however, we saw that the ProTA mentored students achieve significantly higher final grades and a lower drop, fail, or withdrawal rate than the spring graduate TA mentored students. We surveyed our student population about their experience with the mentor program and found that the ProTA mentored students had a lot of opinions about who they worked with, including how well they provided advice, how often they met with the team, and how useful was that time, as well as whether the mentor was able to answer questions and provide helpful answers. These survey results suggest that mentor work experience was not really a contributing factor to the relationships, as the highest performing and second highest performing ProTAs had a very large range of experience, the highest performing having 10 years plus of engineering experience, while the second highest performing having only 2 years of experience in the field. Overall, students were fairly pleased with the experience. In our results, we found that teams mentored by professional teaching assistants improved in their sprint retrospective and final grades, but received more critical evaluations, but these were not significant. Overall, there was not a significant impact in assessments, so our view is that at least we did no harm. There are several confounding variables to our experiment. These included the fall and spring populations being very different in size, as well as their degree progress. The spring semester students are a little bit behind or out of sync with the regular population, and there is also a great variance in the projects and sponsors as well as the mentors. We only had 4 mentors in this cohort working with approximately 130 students, which introduces a lot of variance. Additionally, the instruction teams change between semesters, which can greatly influence the performance and overall organization of the students and their projects. We'd like to share some of our lessons learned and best practices for running a program like this. As for recruitment, it's best to utilize the professional alumni networks that you have access to. We used LinkedIn as well as our alumni tracking system and our contacts with industry sponsorship to recruit professional TAs. Providing a detailed onboarding process that includes guidelines and best practices for mentorship, academic integrity, and FERPA guidelines was critical to make sure that the mentors were abiding by the rules of education and providing a good experience for the students. We also saw that matching the skills of professionals with the needed skills on the teams was very important. If we did not do that, ProTAs were not able to contribute meaningfully to the team's technical guidance, and they were perceived as a hindrance rather than a resource to the teams. Additionally, we started out with loading the ProTAs with up to 8 teams, and we found that they were not able to dedicate the time that they'd like to the students' guidance. So now we're assigning less than 5 teams or projects per professional teaching assistant in a semester. Overall, this significantly decreased our financial load, as the graduate teaching assistants are much more expensive overall than the professional teaching assistants, and ProTAs provided, in some cases, higher quality guidance on specific things like project management and technical expertise. We see this as a great deal and improvement for our program. Thank you, and if you have any questions or would like more information, you can join during our session or contact me at ryan.muth@asu.edu.